Dear students, today we'll see what do we mean by pulse amplitude modulation. So here, as I've shown you, the first waveform is the analog signal, which is called as modulating signal or the information signal. It is the message what we want to send in terms of pulses. And then we have taken a train of pulses. This is first pulse, second pulse, third pulse, train of pulses with constant amplitude, constant pulse width and constant position. So if you see the amplitudes are constant. If you see the width of the pulses, they are also constant. If you see the position of the pulses where the rising edge comes, they are also constant. The time period t is constant. So these are train of pulses who have all the three parameters, amplitude, width and position constant. Now what we are going to do is, we are going to multiply both this, analog signal and train of pulses. Once you multiply them, then the amplitude of all these pulses will take the amplitude of the analog signal at that particular instant of time. Say for example, if you speak about the first pulse rise here. This is the rising time. So it is going to come something like this. What is shown here? So this is the first pulse. First pulse is going to take this amplitude. So it has taken. So here you can see the first pulse has taken the amplitude at this instant of time. At this instant of time. So the amplitude is same what it was here. The second pulse will take this amplitude. So it is shown here. The second pulse amplitude is shown here. So it is going to take amplitude at this instant of time. So this amplitude is going to take, it has been shown here. The third pulse will take the amplitude what is shown at this instant of time. So that is shown here. So this is the first pulse, second pulse, third pulse. The amplitude here was constant, but now they are taking the amplitude at that particular instant of time for which the analog signal was having, or for which the analog signal was going to vary. So even here if you see the fourth pulse, it will take the negative amplitude because we are showing two polarity waveform. So it is going to take the negative amplitude at that instant of time. If you see the fifth pulse, so it will also take this amplitude and it will show negative. If you take the sixth pulse, it will take this amplitude and it will show as a negative because we are showing two polarity PAM wave over here. So we are having positive and negative both pulses, but they are going to take the amplitude of the analog signal, of the information signal, of the modulating signal at that particular instant of time. What the amplitude was, that only they are going to take. So here we see the pulses are having constant width. The width is constant. Here you can see the width is constant. Width is not going to vary. The position also is constant. This is time period t. Here the position also is constant. Time period t. Even here the position is constant. Time period t. Position also is not varying. What is varying is amplitude. You can see this amplitude is varying from here. Here you are having this amplitude. Here you are having this amplitude. Here you are having this amplitude. Here negative amplitude, negative amplitude. And all these amplitudes are varying according to the modulating signal. So it is called as pulse amplitude modulation. It is called as pulse amplitude modulation. Now here we have shown natural sampling. We have shown natural sampling because it is going to vary according to the analog signal only. But the best way to take is also flat top sampling. You can also take flat top samples. So flat top samples will give you the correct amplitude. So here as an example we have shown natural sampling. So you can take a natural sampling or you can take flat top sampling, but the amplitude of the pulses should vary according to the variation of the modulating signal. So if you have this kind of waveform at the end where the amplitudes are varying according to this variation, then it is called as PAM signal or pulse amplitude modulated signal. So after knowing this, we can go to see how do we generate a PAM signal. Now students, we will see a generation of PAM signal. So as I have shown you in this diagram, a circuit whose input will be analog signal. So here you have shown an analog signal. So this is your analog signal or the information signal or the message, anything you can call it. This is your analog signal, and the output should be samples or pulses which will take the amplitude of the analog signal, which will take the amplitude at that instant of time of the analog signal. So these are your pulses which will come at the output. So this is the input which is called as analog signal. Now this input is given to a gate, and that gate will be enabled or disabled with this below circuit. Now here you are having a unstable clock. This unstable clock will produce train of pulses at a frequency, that is sampling frequency fs, greater than or equal to twice the highest modulating frequency. So whatever is the highest frequency of this analog signal, twice of that, and more than that should be your sampling frequency. So sampling frequency fs, that is number of pulses per second, should be greater than or equal to twice the highest modulating frequency of this. So twice fn. So it is going to produce all those pulses which are going to have frequency fs. So here you are adjusting the frequency fs. Now these pulses is given to the trigger input of a monostable multivibrator. So here they are given to the trigger input of the monostable multivibrator, which is also called as one shot. Then the monostable multivibrator will produce proper pulses with constant amplitude, constant width, and constant frequency, constant position. Now these pulses, when they are given to this gate, whenever a rising pulse comes, whenever the pulse is risen, whenever it is rising, that time the gate is open. The gate is open for this time period of the pulse, for this width, whatever the on time is there, that T on, for that time period the gate will be open, and that particular sample of that continuous wave at that instant of time will pass. Say for example, the first time the gate is open, the first sample, this is passed. This is passed. Whenever the falling edge comes, that time the gate is closed. The gate is closed till the next pulse comes into picture. So when the gate is closed, there is no input which is going to pass to the output. So there will be no input. So this is the off time. Then afterwards, when the next pulse comes, again the gate is open. Again the next sample at that particular instant of time, as shown here, this will be passed. This will be passed. Again at the end of this, the gate is again closed. That means no input is going to pass. Again with the third pulse, the third sample will pass at that instant of time, and it will take the amplitude at that instant of time. So you have shown the third pulse here, where the amplitude again is varying. Again at the end of the third pulse, the gate is closed, there is no output. Now in this way, all these samples which are going to come out will take the amplitude of the analog signal at that particular instant of time. So these samples are varying according to the variation of the information signal. The amplitude of these samples are varying according to the variation of the information signal or modulating signal. That is why this is called as pulse amplitude modulated signal or PAM signal. So in this way, we are going to generate a PAM signal. Dear students, now we will see a detection of PAM signal. Now in this circuit, we are having simple a low pass filter, which is going to work as a envelope detector of every sample. Okay. Now here the input is all these samples which are varied in amplitude according to the information signal at that instant of time. Now these samples are given as the input to this low pass filter. The low pass filter will detect every amplitude, this amplitude, this amplitude, this amplitude, this amplitude, all the amplitudes of the sample, and it will generate a smooth wave at the output. Now this smooth wave at the output is nothing but your modulating signal, your recovered message signal, and that message signal is recovered from the variation of the amplitudes of these samples. So this is your detection of PAM signal.